So this problem comes from quiz number 2 from your summer homework. It's on chapter 3 in the book, and it's problem number 1. It gives us this balanced equation, tells us we have 31 grams of aluminum, and it wants to know how many grams of sodium will be made in the reaction. This is a simple grams of A goes to grams of B. So I'm going to start with my 31 grams of aluminum, and I'm going to then find how many moles of aluminum, so that's grams of A to moles of A. Then I find moles of sodium, moles of B, and then I finally can get to grams of sodium. So this is the path that I'm ultimately going to take. Now when I turn this into a T-chart, you'll notice that it has 4 columns, like any gram to gram T-chart will. And I drop down my units diagonally, so grams of aluminum would come down here. I do not carry the number, moles of aluminum down here, and moles of sodium down here. You'll notice that column 3 is moles over moles, so this is the mole to mole ratio. In front of Na in my balanced equation, I see 3, so I put a 3 here. In front of aluminum in my balanced equation, I see nothing, so I put a 1 here. My second column and my fourth column are either moles per gram or grams per mole. So this is where I'm going to use the molar mass in 1 mole of substance. You'll notice the 1 always goes with the mole, whether or not it's on the top or bottom. The molar mass of sodium is 23, and if I take a look at my periodic table, the molar mass of aluminum is 27. So I'm going to multiply the top through and then multiply the bottom through and then do top divided by bottom. I notice that these units all cancel. So my final units I'll be left with are grams of sodium. And when I take out my calculator and put that in, why don't you do that right now? I get 79.2. The reason I'm only writing 79 is because when I look at the number I started with, it was 31. That's 2 significant figures. So this number should also have 2 significant figures.